Hello and welcome back to let me think for a second, part 6, right? Yeah, part 6. So yeah, last part we ported the old clay version over to the new one, and in this episode we're going to start on the Lunar lander inspired game. So you should have something that looks like this, where with the buttons and this center window. Yeah, so what we're going to focus on today is this center window, in which we're going to put a render texture and render our game into, and then show that render texture in the center here. So if you think about this for a second, if you think about the loop, like, let's see if I can get some, yeah. So first we like create clay layouts. This is going to be crude. Actually, let me do like this. Let me resize. So first, to get this working, we are creating our clay layout, and after that, I don't want an arrowhead left, thank you. And so we create the layout, then we render the layout. That's the current iteration. So what we want to do now instead is create clay layout. We want to grab hold of the, what should we call it, game view element from clay. Then we want to both render the layout and we want to render the Lunar lander game. And this is possible because we have created a layout and grabbed hold of the game view layout. So that's what we're going to do. So let's begin. I'm gonna bring up my reference real quick. I'm gonna go up to the top. Yeah, so at the top, up here, we're going to create our handle, which is the cloud layout element, and that's gonna be like the game view element. Then we have some structs. Sorry, there we go. Then we have some structs, or one struct. Let's call this, I don't know what to call this. Let's call this game window struct. We're going to create an instance of that, and inside of here we're going to store some stuff. We're going to store a rectangle for the window. We are going to store a render texture to the game texture. Maybe if we have the struct name game window dot rect game window dot texture, maybe that's better. We don't need to prefix this. And we will have a boolean called like has loaded texture, since we're only going to do it once and we can't do it at the start. And we want to just initialize the has loaded texture to false, like so. Alright, let me also just check. I have spaces, whatever. Cool. So what we want to do next, I think what we want to do, let me just somewhere around, let's see, there, yeah. So down here, so this is this one this element is this element for us. It's between the two sidebars, sidebar 1, sidebar 2, and it's inside the center container, this one, and above the center container is header, and below the center container is the footer. So this is the element we want to grab hold of. So that's the game view element. And we can, inside a clay element, we can use a function called clay get open layout element. Since what this essentially does, if we look inside, this one does a clay open element and a clay close element, and inside of here this code is ran, which gets the open layout element. So we get a pointer to the element. This is so we can get the width and the height and the position. So down in our main, now that we have our main, let's see. I'm just gonna check through. Yeah, cool. So we update our states. We create our layout and we render it. So after creating our layout, we're going to ask if the game view element, if we have found it, so if it's, we can just do this, if we have found our game view element and our game view has not loaded a texture, in that case we are going to do some stuff. We are first going to let's see, we're going to get the bounding box of the game window. So we first off get the hash map item. I'm gonna start doing this for variables, and I should do that for this one as well. Let me just check. So it's recording. Cool. So, and we are going to call a function called get hash map item. We're going to pass the game view element ID. So this gives us a element hash map item, which I think what this one has, I guess this is the actual element, like the data for it, and from that we're going to get the element. What should we, let's call it the element, let's just call it the bounding box, which contains the position and the size. Cool. So now we can tell our rect to be equal to a new rect angle. Can we do this type name? I'm not an expert in C apparently, but we can just do width. And the width is gonna be the element, not the bounding box width. And same for the height, and then we're gonna get the x and y. So the bounding box dot x, and same for the y. Cool. So that's our window. So now we can create our render texture. So game window. Texture is gonna be a new load render texture, and that's going to be, the size is going to be game window dot rect dot width dot rect dot height, and we're going to raise the flag that we have loaded. Cool. So let's see. So So that's this part, grabbing hold of the game view element, and I guess we're doing some kind of initialize a render target. That's this part done. Now we're going to actually do some code that renders into that window. So we can just check if game window has loaded texture. That means we have something to render to. We do it in texture mode, and we are rendering to game window texture. And we can start by just maybe clearing color, same as before. We are going to end the texture mode, and we can maybe just let's draw a rectangle. And right now let's do draw a circle. That's much easier. Let's do it by this. I need to look up how to do that. Yeah, anyway, center X. Let's place it somewhere like 50 by 100. Let's make the radius 20. Let's make the pink circle. This one can be removed. Cool. So here we're rendering to our texture target, and then we have to take the texture target and draw it to the screen. So let's do that down here. Again, check if we have loaded the texture. So this one is going to be quite big first. We're going to do scissor mode, and we are going to scissor out. So we're going to do window rect X, game window rect Y, game window rect width, game window rect height. Okay, then we're going to end scissor mode. So now we're inside. I'm not sure if that's a good illustration for scissor mode. Maybe you know what it is. I can show. Yeah, something like this. We're just creating a rectangle into which we don't show anything outside. I don't know. Yeah, I'm not going to go into it much more than that. And now we're going to actually draw the texture. So we're going to use the Draw Texture Pro. Let's bring up the arguments for. Whoa, this is. We have the source code. That's not what I want. I want the declaration. So draw texture pro. So just open the raylib.h file so we can have it to the right, back to the left. Draw texture pro first. We're going to pass the texture, then we're going to place the source rectangle. Oh right, that's how you do. That's how you do initialization. See, that's the source. Maybe this will become more readable if we create a variable up here called source. And we're going to have a rectangle for destination. And the destination is just going to be game window rect. And the origin is going to be 0, 0. Yeah, I guess that's enough. And the source one is just going to be, we could pass 0, 0, and we can maybe try that, but we need to flip our texture vertically. So because if we just take it as is, when we render, if we render it again, it's going to be upside down because of how the built-in pipeline works. We get the the texture back upside down. So we flip it by doing 0x, 0y, same width, but the minus of the height. Flipping. Flip an awesome source. And then we have the destination. And actually it wants texture first, of course. So we have to like so. It wants texture 2D or texture 2D. We're not doing this course function. Let's continue on. We'll fix it. So destination, then we have the origin, which is going to be a vector 2 at 0, 0. Then we have the rotation, we have no rotation, and we have a tint color. We have no tint, so just white. Cool, but it's complaining because argument of type render texture 2D. You think about the parameter of texture 2D. Let's see. No, right, because this texture is a render texture, but we want the source of texture. Yeah, that's kind of ugly. Maybe we should rename this texture to render texture. Keep it. So this should work. Let's try it out. I'm going to build make and run. Super awesome. Oops, I accidentally resized. We're gonna disable resizing. But now we have something. It's rendering a circle. Wow, that's awesome. But we want more than a circle, of course. So let's keep on moving. We're gonna create 2 new files. We're gonna create the Lunar lander H file. And this is gonna kind of keep related stuff that's related to the game. Yeah. So I'm going just to copy paste in some constants that I have found to work. And these constants are related to the terrain generation we're going to implement. And I have a struct called line, just for we don't have to keep track of 2 separate vectors into different arrays. So we're just gonna keep one array of all the lines. Cool. And then we have our main struct. We're gonna call it Lunar lander. And in here, we're gonna create some variables. We're gonna have the array of lines, which essentially makes up our terrain. And we need start index and we need a end index. For the start pad, and we need a start and end for actually, yeah, goal end index. And I'm gonna not use index, instead I'm going to use idx. It's usually what I prefer. But then we're gonna have 2 functions for now. One called Lunar lander init, which takes in a screen width. That's the screen width of the game window, not the entire application window. And the screen height. And then we're gonna have a Lunar lander render. That's it. Let's create the implementation. Lunar lander C. Sorry. Let's see. Yeah. So we're gonna have some includes. We're gonna have time.age to seed the random engine in Raylib. And we're also gonna use, no, actually that's it. So lunar lander init, which in the screen width and the screen height. So first we're gonna seed the random engine, so it's not the same every time. So I'm just gonna write out the algorithm that's going to create the terrain and how the algorithm works. It's nothing complicated. Let's walk through it. First, we have our constant, so we know the distance between each line, something like this, and then we start somewhere. Let me just look. Yeah, we have a start y, which we defined, and then each step we're taking one step and we are adding some noise, like boom. So then the line becomes here. And then we take another step and we add some more noise. Maybe it goes down. Take another step, maybe it goes up. Another step, maybe it goes more up. Yeah, so you can see how we get something that looks like this, and then you do this for the entire map. And so we have a starting and end position as well, and that's just picking between two random points. So maybe you want to start here. In that case, this line wouldn't exist. Oh, I erased the whole thing, whatever. That line would exist, and this line would connect there, and then it would keep being random. And somewhere around here to the right, we will have the end and the end start and the end, the goal start and the goal end index, which again just draws a straight line between those 2 points, and then it continues on being random after that. Yeah, so that's basic, and that gives kind of the same look as this original Lunar Lander game, which looks something like this. We are of course going to tweak this later, but for now we're going to implement it as is. So I'm just gonna crack on. We have the start y, which is going to be line start y. And we have some, as I said, delta, which is just going to be whatever width we have on the screen divided by the number of lines we are going to make up the terrain. And then we are going to pick to the left we're going to pick the start position, and to the right we're going to pick the end index. So I'm going to copy paste in those lines. Of course we haven't initialized our lunar lander struct. Let's do that then. Misspell. This is a normal pattern in C, where we have this publicly exposed side, which we're going to call into these two functions, and then the implementation handles the ownership of a lunar lander object and uses that one only in here in this compilation unit. We named this variable LL. The same for lunar lander, and it's complaining. Yeah, because we used IDX as I previously used index, so let's remove that. IDX, awesome. This is just picking the picking the start position, and it's to the left, and this one is just picking the goal position, and it's to the right. And then comes the main algorithm. So we're going to loop, you guessed it, line the number of times, of course. I see an error here, so I'm just going to ignore the default here. This is wrong. So the last y is going to be start y, but this is wrong. Last y should not always be start y. We're going to fix that later. And then we have some amount of random offset, which we can get from getting random value. And we have a threshold of how much offset we apply each time. Let's see. Actually, it's this one is not wrong because I'm just dumb. So now we of course, if y is not equal to 0, meaning we are not at the first index, then we say that last y is equal to lines at index -1 dot was n dot y. If that makes sense. So we can't grab the last y the first time around since we have nothing before, but in all other cases we have something to the left, so we can do -1 and grab that y value. And then I'm going to copy paste some. There is this part, which just check if we're plotting the start or end, or start or goal, and this becomes LL, and index becomes IDX. Cool. So now we can insert a line into the terrain. So we do this by simply creating a line. This one is going to be a bit messy. I'm just gonna copy paste. Yeah, I'm just gonna copy paste this part, and then you can write it out if you are following along. So a line in our case is just a start and an end, and it's a vector 2. So we're going to use start and end. What I'm actually going to do real quick, for the sake of doing it, I'm going to create a helper function called xy that takes in 2 floats and returns a vector to xy. And I'm going to use this here. So x last y. So then start is equal to xy x last y, and the end is going to be x plus delta x and a random offset. Or is it? No. Random offset. Random offset is just a number. Shouldn't this be like last y plus random offset? Maybe that's a fault from my previous implementation. Let me see. Yeah, so we create a line, and then before we are done, we increment x by, so we step forward. Cool. Not that complicated. And the last function for today is the lunar lander render. And this function is simple. We're just going to draw all of the lines we have created. So again, we iterate line number of times, and we're going to not use capital Y here. We're going to vary the color. So if we're on a goal or on the start, we're gonna have a green, and if we're on the goal, we're gonna have a red. We might change that in the future. So color, and we're gonna use the same booleans as before, and then we're going to ask, like, are we plotting the start? In that case, set the color to like green. If we are plotting the goal, set the color to red. We can maybe decide on a color. No, that's a bad comment, because the comment doesn't. The comment just explains what, not the why. And now we do draw a line. Let's see if we can use draw line V this time, actually. Let's think, yeah, so this is going to be LL lines at the Y start, and then it's going to be LL lines I end, and then the color. Sorry for my hiccups, I'm just thinking. Yeah, this is fine, this will work. So actually draw the line and pick a color. Cool, I think we're done. So let's go back to main and let's include our new file. So lunar lander h, and then down in the main. So we can't, you might intuitively call lunar lander init here, but we don't know the width and the height of the game view, because we have to build the clay layout first. So we can instead call init down here, since down here we have knowledge of, this is the first time we have knowledge of the game window width and the game window height. And down here where we drew the circle earlier, we're gonna call lunar lander render. Cool. Let's build. Or, you know, one last thing, we have to include the new file here in the CMake file. So maybe we need to CMake again. No, maybe we can build. No. Oh, we have an assert. Maybe I copy pasted an assert. I did. There was an assert here for the picking. We can keep that. You know. So I like to use asserts whenever I'm a little bit unsure about my code. Like, I'm not super sure about how the get random value worked. So just to like keep me from running into bugs or something in the future, I just put an assert of what I expect from like the slightly unknown function, and that way I can kind of not have to worry about it until something, if it breaks. Cool. That's our terrain. So we can say we have some bugs, like the line is the line is going out of the screen. And for that we should probably put in some protection, like if the line end is underneath, if the new end is underneath the game window height or larger than the game window height, we should just invert the offset if the offset is positive. Kind of. But other than that, this kind of works fine. I mean, if we look at our inspiration, it's kind of similar. We could maybe increase like the granularity a bit so it goes more up and down, but I'm not sure they are using the same method I'm using, because they have a lot of up, and then they have a lot of down, a period of nothing, then a lot of up, a lot of down. So they seem to have, it's almost like it's noise, or like a sinus curve. This is outside the scope of the code. We're done with the code, by the way. So that's it for part 6, was it? Yeah, that's it for part 6. So we can let it go. Let me see. Yeah, I'm just gonna like kind of check something. So say you have this sinus thing, and let's make it above 0. Like you can I want to look at the positive. Let's ignore the negative. Something like this. Like, how do you randomize this? I'm not that good at math. What's this? This is nothing. This is not any more random than before. Let's keep this one. Like, what if you change the frequency? That's more random. That's much more random. So this has some properties of like going down for a while, then going up, then going down, and up, down, up. So what if you like scale this to, you would like to scale this 0 to 1. Can we scale the axis? X-axis. Can we like scale it 0, 1? Yeah. And then scale this one. I'm not sure how to scale this one, whatever. So if you increase this, maybe 30 is a bit too much, like 15. And then this one, no. What does this do? This does not a lot, actually. Something like this. And then you would we could calculate the derivative, and that way we can have a random offset in our like discrete line. So it's negative, negative, then we have a positive offset, negative. Yeah, kind of like Wolfram alpha derivative of this. I'm not going to implement anything, I just want to know. That's correct. Derivative. That's the derivative. That's something we could use, maybe. If I do that, maybe I'll include it in a video, not sure. Awesome. Next video we are going to put in the actual lander. We're going to render a spaceship, and we're going to give it gravity and some forces. And the forces, like we're going to actually hook up the buttons so that the buttons affect the spaceship. So that's going to be fun. Yes. Alright, thanks for watching and see you next time.